So today I'll be doing exercise 40 from chapter 14 in our physics notebook. It states posture hypotension is the occurrence of low systolic blood pressure when a person stands up too quickly from a reclining position. A brain blood pressure lower than 90 millimeters of mercury can cause fainting or lightheadedness. In a healthy adult, the automatic constriction and expansion of blood vessels keeps the brain blood pressure constant while posture is changing, but disease or aging can weaken this response. So the actual question states, if the blood pressure in your brain is 118 millimeters of mercury while lying down, what would it be when you stand up if this automatic response failed? Assume your brain is 40 centimeters from your heart and the density of blood is 1,060 kilograms per meters cubed. So in this problem, we're talking about some type of flow. We're talking about blood flow in this case. So to think of what equation we're going to use, just think of what we have. So we're talking about some type of flow, some fluid flow. In this case, blood flow from your heart to your brain. It gives us pressure, it gives us a distance, it gives us density of blood. So because of these elements, you should automatically think to use Bernoulli's equation, which has to do with fluid flow. It has to do with pressure, has to do with distance, velocity. So this is the equation we'll be using today. So first, write our notes. So our first pressure is 118 of mercury. We know the blood density and we know the distance from the heart to the brain. So we're going to use this equation and we're going to solve for the second pressure, which is what it's asking of us. So if you solve for it, I'll put this in. If you solve for it, this is what you get. Okay, and then as you can see, we don't have any type of velocity. And this is because our blood pumps at a uniform speed. So in this case, it doesn't tell us anything that the blood is not pumping in a uniform speed. So we're going to assume that velocity 1 is equal to velocity 2. And given this, we are able to cancel out some things. So if velocity 1 is equal to velocity 2, so I'm just going to put a 1 there, we are able to cancel these out. Okay, once we cancel them out, we get this. All right, and then I'm just going to take out the density of blood and the gravitational constant. So we're left with this equation. And this is our distance. So we know our distance is 40 centimeters, so we know that. We're just gonna convert it to meters. We know our blood pressure, the density of blood, the gravitational constant, and the distance. So when we plug everything in, this is what we're left with. And once you solve it, you are left with this. So these are different pressure units. So we're going to convert this to millimeters of mercury. So this is actually in pascals. So let me just do that conversion really quick right here. So in 1 Pascal, there is 0.0075 millimeters of. So that's going to give us 31.164 millimeters of mercury. So we're just going to plug this back in here. So 118 minus 31.164 is about 87 millimeters of mercury. So that will be our final answer. So due to this malfunction, this will be your second pressure once you stand up. And if you go back to the question, it says if your pressure is less than 90, you will either faint or you will feel lightheaded. So in this case, you will feel lightheaded or you will faint. So that's the final answer.